Hello everyone. Today we discuss about the processes available in the operating system chapter. This is the chapter 3. Here we are discuss about the process concept, process scheduling, operations on processes, IPC, that is mean inter-process communication, IPC in shared memory, IPC in message passing systems, and IPC examples, and at last communication in client server system. First, the process concept. What is mean process? First of all, a process is a program in execution. Process execution must progress in the sequential fashion. No parallel execution of instructions of a single process. This is the concept of process. In an operating system, it executes a variety of programs that run as a process. So we can, first of all, a process is a runnable program. In a OS, a runnable program is called a process. That is the main concept. Here the program code has the test section, program counter, processor register, stack, data section, and a heap. These are all the multiple parts of a program to develop a process in an operating system. These are the main concept of a process. Simply said, a process is called a program runnable in a operating system. That is mean a process. Like already we discussed, the execution of the program is called a process. This is the process in the memory. First, stack, heap, data, text are available. Here the free space are available. In the free space we can access some process like a data section or a project or a files, programs, etc. This is the memory layout of a C program. First of all, the C program is a simple C program. This diagram is give the explanation of a C program how to run in the processor. First, the stack and the heap. Here the between the stack and the heap the process are available. For example, the a.c is the C program, means you occur the C program and run the program full. That is the memory layout of a C program. This is the process states. There are 5 types of states are available: new state, running, waiting, ready, and terminator. These are all the 5 states, process states are available. Here new state means a new process are created, means the new state. Running means the instruction are being executed or running state. Waiting means someone event to occur, so the process is till waiting. Ready means it is ready to assign to a processor to runnability. And then terminated means the process has finished the execution successfully. These are all the 5 states available in the process state. This is all the diagram: new, ready, waiting, running, terminator. Next we discuss about PCB, process control block. What is meant by process control block? Simply, process control block means it is the building components are available here. First, process state, next process number, process counter, registers, memory limits, list of open files, and the free space. Process state means what is the state, running or waiting or terminated, what. And the program counter means location of the instruction to execute. Program register means the generic registers available, the CPU. CPU scheduling information means the priority and scheduling queuing pointers. And the memory, which memory can the process access. Accounting information is the CPU used clock time. And the last of all, the input output status. These are all the PCB, process control block. And the thread, another one is thread. Thread is a lightweight process. It is the distribution of the execution is called the thread. It considers the having multiple program counters per process. These are all the thread concept. The process representation in Linux commands, it is the example of the process representation. And then process scheduling. The process scheduling is based on the process scheduler, scheduling queues, ready queue, wait queue, something. This is the basic of the process scheduling. Ready and wait queues. If the process ready means okay, the process can access and terminate successfully. There are the long queue are available means the process wait some time. This is the presentation of a process scheduling. Ready queue, wait or terminate, and go to CPU, and the process will finish this process successfully. This is the CPU switch from process to process. Process 1 P0, P1 two processes are available. How to the CPU switch from one process to another process. This main concept is called as the context switching. Switches from the one process to another process. This diagram is the explanation of the context switching explanation. Context switch definition means the CPU switches to another process. The system must save the state of the old process and load the saved state of the new process is called the context switch. Context switch is the process representation in a PCB also. So here multitasking available in the mobile system to run the processor. The main operations on process is process creation and process termination. First we create a new process, and last the process finish the process terminate the process successfully. These are all the two operations on a process. In this two state, the 5 state of the process are included. Example, ready, new, ready, waiting, terminate, etc. So these are all the basic components and the basic things about the process available in the operating system. And next session we can discuss the another chapter. Thank you.